Hello. In this lesson, we will look at the pipeline recognition function when working with technical objects in the 3DScan program. During our next lessons, I recommend using the help, which will describe all commands and their parameters in more detail. To call it, you need to press the F1 button when using the command. You can also open the 3DScan tutorial using the Help 3DScan button on the Point Clouds tab in the Help group. First, we need to import the model into the program. To do this, in the Point Clouds tab, select the Import command in the group of the same name. Let's open our source file. After a short amount of time, the Point Cloud Import Settings window will appear. Leave the units field set to meters, since the drawing was done in meters. In the thinning field, leave the value Don't Thin Out. Let's take a closer look at the Upload field. We have a large number of metadata associated with each point of the cloud. I highly recommend importing only the data you need for your work. In this case, we need all this data, so we will leave all the checkboxes unchanged. To the right of the metadata are information codes. Point cloud points can be classified, meaning each point can be assigned a code attribute, which is essentially a number that can be described as layer separation in CAD system terms. You can read more about these parameters in the Help by pressing the F1 button. Next, in the Import Settings field, leave the value millimeters. Below, there is a setting that allows us to split files into separate clouds. This can be done by various suggested methods. Let's leave the value Don't Separate in the field. If necessary, we can import not the entire cloud, but only a part of it using the On-Off selection command. Let's deselect the area and click the OK button. Right after importing, save the file. In the Settings group, use the View Mode command and set the coloring field to Scan Color. Let's switch to the left view and use the Clip by 2 points outside to trim the excess part of the cloud. Changes can always be undone using the Undo Clip and Reset Clip commands. Don't forget to save this point cloud with the clipping applied using the Create from View command. Now let's switch to the 3DScan tab, where in the Features group, we will use the Search for Pipes command. After a short amount of time, options for changes will appear, as well as parameters for pipeline recognition on the left. Let's set the following parameters. Save type to class, no. Neighbor count, 50. Let's measure the pipe width and set the radius based on the measurements. Let's set the following parameters next. Max pipe radius 500, min pipe radius, and group tolerance 0, slice thickness 10, local averaging, count 50, filtering distance threshold 15, ax threshold 10, surface epsilon 15, min ax size 50, bitmap epsilon 1000, detect flanges, and delete axis cloud, no. You can read more about these parameters in the Help by pressing the F1 key. The command line option Scale Linear 1000 allows you to increase the dimensional parameters by 1000 times to reduce the amount of manual adjustment. Apply the changes by selecting Yes from the list of options. After some time, the geometry will be recognized. I recommend saving the file under a new name so that we always have the option to return to the original version. We may notice that in some places, the pipelines were not recognized. One of the reasons why the pipelines were not recognized is the small slice thickness. Let's switch to the top view and use the clip function to leave only the part that was not recognized to speed up the processing. Use the Search for Pipes command again. In the parameter settings, change slice thickness to 100 and local averaging count to 20. As we can see, the unrecognized geometry is now defined. Let's do the same for another section, but first, undo the clipping using the Undo Clip command. Use the Search for Pipes command and then change the slice thickness parameter to 50. If necessary, the recognition procedure can be run again, for example, by changing the recognition parameters. Only unrecognized points will be involved in the repeated recognition. The colored parts shown in the figure are not newly created nanoCAD primitives, but grouped points of point cloud. In fact, the points are grouped by shapes. Points of the same color belong to one shape. The following types of shapes can currently be used: pipeline cylinder, pipeline elbow, pipeline diameter change, pipeline T. We can see the recognized shapes by clicking the Edit Features button in the Features group. For convenience, let's move this panel to the right side. By selecting objects in the panel, we can see how our recognized geometry is reflected in the drawing. Using the triangle, we can expand the information about the geometric object, which we can also edit. At the top of the panel are all the necessary commands for working, which can also be found in the Features group. Now let's select the Select Feature command on the panel and examine the interaction with the geometry. The main snaps for working with geometry are Shape Axis Node, nearest point of the shape axis, and Shape Center. It is important to enable the Snap Point Cloud and Snap to Features functions in the Settings group on the Point Clouds panel to ensure correct snap operation. For example, let's select this pipeline. When zooming in, we can see the editing handles that allow us to edit the diameter, length, and position of the recognized geometry. Let's connect the coaxial pipes. First, we need to measure the radii of the pipelines. This can be done using the Determining the Radius command in the Point Clouds panel in the Information group. The diameter value of this segment of pipe is 189. And that of the neighboring segment is 187. From the measurement results, we can see that the maximum value is 189, and the minimum is 187, so the difference between them is 2. Now select the pipeline using the Select Feature command and choose the Merge Coaxial Pipes command. Pay attention to the settings on the left. Set the ax distance parameter value to 10 and the max radius difference parameter based on the radius difference calculations. But set it not to 2, but with a margin 5, and set the angular threshold parameter to 1. As we can see, the pipes for merging are highlighted. Apply the changes using the Yes command. Next, using the editing grips, we can extend this pipeline to the desired size. Let's trim part of the drawing using the Clip by 2 points outside, where the geometry was incorrectly recognized. Select the object using the Select Feature command. We see that it is displayed in the Edit Feature panel. Right-click on it and see the interaction options. Since this geometry was identified incorrectly, let's delete it by selecting the Delete Feature option or a similar command at the top of the panel. Remove the incorrectly recognized geometry from the drawing We can also use the Isolate All Features command to isolate all the geometry, or unisolate all the geometry using Unisolate All Features. For example, let's isolate several pipelines. Or if we isolated a specific pipeline object, we can use the Show All Features command to display pipelines. Let's close the Edit Features panel. When we have recognized all the pipelines and edited them as needed, we can create geometric objects using the Creating Objects by Features command. Let's use it. Click on the point cloud and pay attention to the settings in the panel on the left. Let's set the coloring field to By Feature Color. Apply the parameters by selecting the Yes option. Now we can select these objects and see that they are 3D solid objects. Undo the changes with Ctrl-Z. Sometimes manual recognition of pipeline geometry can be used. For this, the Tracing Pipes and Planes command is used. Activate it, select the cylinder parameter, and make adjustments to the parameters. Leave the Neighbors Type parameter unchanged. Set Neighbors Count to 100, Filtration to 10, Slice Depth to 800, Slice Width to 0.8, Accuracy to 5, Segmentation Epsilon to 8. Let's specify a few pipelines. As we can see, manual recognition of pipelines provides lower accuracy compared to automatic recognition. Undo the changes with Ctrl-Z. Let's consider another interesting command, Creating a Pipeline Route, which performs the task of creating a pipeline route and outputs a 3D polyline that can be used for pipeline modeling in specialized software. Before creating the route, it is recommended to create a separate layer and make it current. Let's set up a world coordinate system so the grid doesn't get in our way. Activate the command and now specify the first branch of the pipeline. We see that there are branches. To initialize them, use the branch command, which we can see in the command line. Select this option and specify first branch of the pipeline. Select this option again and specify second branch of the pipeline. After specifying all the branches, choose the Done option, and we see that a 3D polyline has appeared. Let's look at the final stage, when we have already recognized all the geometry, and now we need to transfer the pipelines to another program. For this, the program provides the ability to export to the PCF format using the Pipe Export command. Let's hide the original point cloud. Let's use this command, click on the lines that were created during recognition, and specify a file name. Click Save. And the file with the geometry is saved in the PCF format. This concludes our lesson on recognizing pipelines when working with technical objects in the 3DScan program. Thank you for your attention. See you in the next lessons.